Page 678, lesson 11.3 is on dividing polynomials. There are different cases that we're going to have when we're working with dividing polynomials. Some of these problems will be a little simpler to work out. Some will be a little bit more complicated. We'll start with the more simple problems. So if you look at this on page 678, this is an option where we're dividing by a monomial. So they want us to divide all of those other parts basically by 3x squared. Well, divide the whole thing by 3x squared. What we can do then is we can just take each part, each of those terms, and divide each one by 3x squared. So dividing each one of those by 3x squared, and then that gives us, basically here the x squareds you could just say cancel out. So that would end up giving you 3x minus 2 plus 5 over x. So let's go ahead and look at the got it one. So there's not a whole lot going with these. I think you guys can handle this pretty well. So we're only going to look at one of these. Let's look at part B. And the directions are divide. So we're dividing. We have a trinomial divided by a monomial. And they could have written it as a fraction also, just so you can see the different looks that you could be given. Okay, so the deal is on this problem is that we're dividing by a monomial. Dividing by a monomial, you could look for greatest common factors and things. We don't have any. And so what we're going to do is we're just going to divide each part of the numerator by the denominator. So each part of the numerator, each term in the numerator gets divided by 5b cubed. So with the first fraction, the 5's can just cancel out. These are factors. And then b to the fourth divided by b cubed. That would just be a b to the first, or you could just say b. And I just recognized that I made a mistake here. This should have been 15b squared instead of to the fourth power. So just to make sure we don't get confused with this. So at this point, the 15 and the 5, you can reduce both of those by 5, and that would give you a 3 in the numerator. And then with the variables, we have one more factor of b in the denominator. So we can factor out or cancel out 2 factors of b. That'll leave us 1 factor of b in the denominator. And we're going to write it that way. We're not going to put negative exponents. So just put it as minus 3 over b for that part. And then the last part, if you'll notice, we really can't do anything with that. So we're just going to leave that just like it is. And we're going to get a lot of answers that might seem unsatisfying in this section. Doesn't look real nice, but that's it. That's all we can do on this problem. The next thing we're going to look at is dividing by a binomial. Dividing by a binomial, we're going to work out things a little bit differently. And so potentially what we could do, if we were dividing this out for problem 2, we could think about it as a fraction. And then you could think about if in the numerator we could factor that out somehow. If we could factor our numerator somehow and get a d plus 3 factor, and then that could cancel with the d plus 3 in the denominator. The problem with that, for one thing, is we have a minus 4d and we have a plus 13, which means both of our signs would have to be subtraction. The other problem is factors of 13 would just be 1 and 13. 3 is not a factor of 13. So for sure we're not going to be able to do that. Okay, it's, you know, one way you could think about it to try to do it before you go into what the book's doing here, but it's not going to work for this one for sure. So if you look at problem 2, what we're going to do then is we are going to do long division. So long division with trinomials and binomials. What we do is the first part, which in this case is the trinomial, the part that's being divided up, we are going to put that on the inside, and it's being divided by d plus 3. So what we're going to do, just like regular division, we're going to look at, in this case though, not the whole thing, we're just going to look at this first part. We're going to look at how many times d can go into 3d squared. So a little different thought process here than just regular numbers, but basically think about d, what would I have to multiply d by to get 3d squared? And the answer would be 3d. So that's how they got the 3d up here. Okay, and then what we do is we multiply. So we're multiplying these together. And when you do that, if you want to work that off to the side or something, just be careful, make sure you're getting the right numbers. Okay, so feel free to work that to the side if you need to. So that would be 3d squared plus 9d. And then what we have to remember in all of this is that normally when we do long division like this, we figure out how many times it goes in, we multiply, and then we actually subtract that part. So we're actually going to subtract that part. And I don't really care for how the book is doing this. They just are kind of like, okay, we're going to subtract, and then all of a sudden we get, you know, that cancels and we get minus 13d and whatever. I think it might be more beneficial if we actually put that we're going to subtract here. And remember, subtracting, we talked about some of this stuff before. When you're subtracting something like this, you can add the opposite. Opposite just changes all the signs inside the parentheses there. And that might be easier for you to look at and see that these actually cancel. And then when you add these together, you get a negative 13d. And then the next step is that we're just going to bring this next part down. So just like you bring the next number down when you're doing long division, we're going to bring the next term down. So we're going to bring down the plus 13. And then now we're going to look at these first terms. So we're going to say, how many times does d go into negative 13d? So d times what to get negative 13d? And that would be negative 13. And once again, at that point, we are going to multiply, which is negative 13d minus 39, and then we're going to subtract. So subtract, we can add the opposites to those. That first part should always cancel out if you did the correct number, and then 13 plus 39 is 52. So this would be our answer after we divide all that out. And as we go through this, if we look at a clean problem without having something that's already worked out, I think it'll make a little bit more sense even maybe as we get more practice with this. If you look at the got it 2, here is what they want us to divide out. Like I mentioned earlier, one thing you can do real quick just to double check it is whether this would somehow factor. So we have an m plus 1 in the denominator. Could we get an m plus 1 in the numerator? So we need 2m times m to give us m squared. We got minus 3, so we need a positive and a negative. And to get 3, we need 1 times 3. So this would be minus 3m plus 2m gives us minus 1m, which is what we wanted. And so actually, the m plus 1s would cancel, and our answer would just be 2m minus 3. So that's not a very good problem to practice, this long division. Well, I guess it is. You could argue it is, because then you can check to make sure it works out the same. But we're just going to do a different problem because that one worked out too nicely. So I made up some numbers, so this is not going to work out nice. So we're going to, let me just write this first as a fraction. So let's say we got 3x squared plus 5x minus 9, all being divided by x minus 7. And remember, if you want to put parentheses around these, don't even think about trying to cancel unless you see a factor that's the same. And so we don't even really have factors here. We just have things being added and subtracted. We have a binomial in the denominator, and so we are going to go with long division here. So long division, we got 3x squared plus 5x minus 9 is on the inside, and it's being divided by x minus 7. So the first thing we're going to look at these leading terms here, the x and the 3x squared, and we're going to think about, I'm not even looking at the minus 7. That's not even a thought with what I'm doing right now. Just looking at what I've underlined there. So we're thinking about x times what to give us 3x squared. So that would be 3x. Now, one thing I didn't talk about in the previous example, we're going to try to keep our terms organized so we can keep track of where we're at in the problem. So when we say that we could multiply that by 3x, I am going to put that right above the 5x. I'm going to put it right above the like term that we have with that. And then again, if you want to work this out to the side, you can. We need to multiply 3x times x minus 7. So we do that, we'll get 3x squared minus 21x. Now, before we get too excited to work out the next step on this problem, we have to remember that we are going to be subtracting this. We're going to be subtracting this, and so we need to add the opposites. So this first part, like it should always do, is just going to cancel out. 3x squared minus 3x squared cancels. And then this would be 26x. We bring down the next term, which is minus 9. So then now we're looking at x into 26x. So x times 26 would be 26x. And again, if you want to multiply this to the side, you can. That would be 26x minus 182. And then we got to remember we're going to be subtracting this. So we can add the opposites here. If you guys want to make this more fun, more colorful, you can use colors, colored pencils or something if you're working these out. This first part's going to cancel out then. And then this would be 173. And I told you I made this up. The numbers are not nice. So this part is what's left. So we have 173 left out of x minus 7 that we were dividing by. So that would be our final answer for this problem. Generally, what's going to happen when you do these problems is when you work it out, most of the time it's going to just go down by 1. The exponent will go down by 1 every time. So like we started with 3x, we had an x term, then we had a constant, and then we had a fraction with whatever you're dividing by in the denominator. Sometimes when you do these problems, there are missing terms, And so missing terms, we're going to get all thrown off if we don't put kind of a placeholder there with a coefficient of 0. So if you look at problem 3, they're telling us the width of the rectangle and the area of the rectangle, and they're asking what the length would be. So we know area of a rectangle is length times width. So if you took the area divided by the width, that would tell us the length. So if you'll notice though, for the area there was not a z² term. So if you look what the book did here, they put a 0z², and that's a placeholder, and it kind of just helps us keep track, and so we can get our like terms above each other and stay organized with what we're doing and get the right answer. So without working through all their stuff, again, they didn't show, the book is not showing the subtraction and adding the opposite on any of these, which I'm not a big fan, as you know. So we're just going to go ahead and work through this. Got it. 3a. So this is at the top of the next page in your book. So first of all, notice we're dividing by a binomial. Okay, if it was just a binomial, if it was just like dividing by q, then we would just divide each term by that, and then we'd be done. As it is dividing by a binomial, we're going to need to do long division. So with this, we need to just make sure we're not skipping over anything. So we have q to the 4th. Notice there's no q cubed term, so I'm going to put 0q cubed. And then we've got q², we've got q, and minus 3. And then we're dividing all of that by q minus 1. And as you do this, any of those that don't have numbers in front, if you want to go ahead and put 1s there, you can. Don't have to, but you got that option. So if we start this out, we are trying to multiply q times something to get 1q to the 4th. So the 1 we've already got, q times q cubed, there's a tongue twister for you, that would be q to the 4th. So q cubed, I'm going to put that above the 0q cubed so I can keep these like terms together. And if you multiply that, that would be q to the 4th minus 1q cubed. And again, if you can do that without working it out to the side, you can. I wouldn't probably put it too close to your actual problem so you don't get confused about this. And then remember that we are going to be subtracting this, so we need to add the opposites here. So the q to the 4ths cancel out like they should. And then we bring this down, 1q cubed, and then bring down your next term, which is 1q². So now we're looking at q, and just do an arrow here so everybody can see what we're talking about. We're looking at q times what to get 1q cubed here. And that would be q². If you want to put 1q², you can. And I'm just going to go ahead and work it out without working it to the side this time. q² times q is q cubed. q² times minus 1 would be minus 1q². And then we're going to subtract. We're going to add the opposites there. And so for a moment, you might have thought that was all just going to cancel, but after we do the subtraction, you can see it's actually not. The first part will cancel, but then that should be 2q². And then we bring down our next term, which is plus 1q. So now we're looking at this q on the outside, and we're looking at the 2q². We're looking at q times what to get 2q². and that would be 2q. And so if you multiply that, that would be 2q squared minus 2q. And then remember, we're going to subtract that. So add the opposites. The first terms cancel, and then we've got 3q, and we bring down minus 3. So now we're looking at this q on the outside, and q times what to get 3q, and that would be 3. So we put plus 3 on the top. Distribute that would be 3q minus 3. And remember, we're going to subtract. We're going to add the opposites. And actually everything cancels. So we don't have a remainder part here, so we don't have to have a fraction at the end. That is just going to be our answer here. So next, if we look at part B, we've got the same idea. And once again, we're dividing by a binomial, so we're going to be doing long division. Notice there's no h squared term, so make sure you put a 0h squared as a placeholder there so you don't lose track of where you're at. And we're dividing by h plus 3. So to start out on this problem, we've got the h on the outside, we got h cubed on the inside. So we need h times what to get h cubed? And the answer would be h squared. We'll go ahead and put that above our h squared term. When you distribute that, that would be h cubed plus 3h squared. We're going to subtract. We're going to add the opposites here. So first part's going to cancel. We've got negative 3h squared. And then we bring down the next term as minus 4h. So again, if we look at these first terms, we got the h on the outside, negative 3h squared on the inside, or underneath, I guess. So h times negative 3h squared would give us negative 3. H times negative 3h would give us negative 3h squared. So this would be negative 3h squared minus 9h. And then we're going to need to subtract that. So we can add the opposites there. So that'll leave us with 5h plus 12. So now we're looking at h into 5h. So h times what to get 5h? And that would be 5. So if you multiply that, 5 times h is 5h, plus 5 times 3 is 15. And it's real easy to forget. Really make sure you remind yourself you've got to subtract. If you forget to subtract, you're going to throw off the whole rest of your problem. Okay, so we add those together, we get negative 3. So this is kind of our remainder piece, if you will. So we got minus 3 over h plus 3, or if you want to say plus negative 3 over h plus 3, that would work also. And remember that h plus 3's got a force field, so you can't cancel anything out there. We're just going to leave it like that. Problem 4, what they're pointing out is that sometimes we might have to reorder terms. So reordering terms is kind of the topic here. So you can see the problem they have to start with. And basically the deal is that these are not in standard form. They're not starting with the highest exponents. So they're just rearranging these. So the thing that we're dividing up, they just rearrange that. You can see down below here in red, they rearranged that as 4x squared minus 10x minus 1. And then the thing they're dividing by, they also rearrange that. You can see in blue, they rearrange that as 2x minus 3. And then at that point, it's just exactly like what we've been doing. So we're not going to worry about going through a problem like that, but just something to think about when you do these problems. Make sure they're in standard form. Make sure it goes from highest powers down to lowest powers before you start working those out. So the concept summary in your book just is kind of a good recap for you of the different things you need to consider. So one thing is arranging the terms in standard form, and if there's something missing from the dividend, you just can put a 0, kind of a placeholder, 0, whatever it is, in that spot so you're not skipping over any exponents. And then you can divide, and then multiply and subtract, and then bring down the next term. And again, this is dividing a polynomial by a polynomial. We didn't do much with it, but if you remember at the very beginning of the lesson, we divided by a monomial. Dividing by a monomial, you can just split it up and divide each term individually by that monomial. So one problem I want to look at with you that's not in your book here, just to give you an example of something else you could see, is let's say we've got 2x to the 4th plus 3x cubed minus 2x squared plus 5x minus 4, and that's being divided by x squared minus 5. So a difference here, we do have more terms involved maybe. One significant difference is that we actually have a squared term in our divisor. The number we're dividing by has a squared term in it. And so if we go to work this out, just like we did kind of a placeholder for what's being divided, we probably would also be good to do a placeholder for the number we're dividing by. So I'm just going to write that as x squared. We're dividing by x squared plus 0x minus 5. Once we get that set up, it's going to start out looking exactly the same. We're going to think about x squared times what to get 2x to the 4th. So that would be 2x squared. Now if you'll notice, we got to shift over a couple. I want to be above my x squared term so I can keep track of where I'm at and when I'm finished with the problem. And then we're going to distribute. We have to distribute that to all three parts here. So we have, this would be 2x to the 4th. And then even though it's a 0, I'm going to write it anyway, just to keep everything lined up. I'm going to put plus 0x cubed, and then minus 10x squared. And then we're going to subtract. We're going to add the opposites here. As always, that first term should cancel out if we've done this correctly. That would be 3x cubed plus 8x squared. So we can go ahead, normally we go ahead and bring down the next term, so we can go ahead and do that, bring down the plus 5x. And then we're looking at these first terms again, so looking at the x squared, looking at 3x cubed, so we'd have to multiply by 3x to get that to work. If you distribute that, that would be 3x cubed plus 0x squared minus 15x. Notice we're dealing with 3 terms here instead of 2 when we're doing our subtraction part. So first terms should cancel out. And then we're going to have 8x squared plus 20x. So before we go further, we'll go ahead and bring down our next term. So bring down minus 4. So x squared going into 8x squared, that's going to go in 8 times. So that would be 8x squared plus 0x minus 40. Remember, we're going to subtract. And so a difference here, if you'll notice, we're at the end on top. When you're at the end on top, what that means is what should be left is just your remainder part, your remainder fraction. And so that's what we've got here. And if you do a problem like this, probably just a modification of this in the denominator, they probably won't have the plus 0x. They'll probably just have x squared minus 5 in the denominator, but otherwise that should match up with the answer that they would have.